All right, let's go ahead and get started in, we're going to look at lessons 10, 11, and 12 in this video. Lesson 10, the first concept we're going to look at is finding the equation of a line, or finding a line. And the way you find the equation of the line, the first thing you do is you always write down y equals mx plus b. M and x are obviously points, they're coordinates, like x comma y. You use something like that. So they are, x and y represent a point. M and B represent the two things you have to find. Once you find the M and the B, you're done. M stands for the slope, or represents the slope, which the slope is the rise over the run. And then B is the y-intercept, and it simply means, if you draw a coordinate plane, it's the y-axis. It's where it intercepts or crosses the y-axis is what the B term is. So that is what you, so anytime they say find the equation of the line, you're going to write down y equals mx plus b, and you all got to solve for two things, and then you're done. So if they give us 2 points, like they do in the first example on page 75, example 10.1, they say find the slope-intercept form of the equation of the line that passes through these 2 points, -3, 2, and 4, comma, -3. If they give you something like this, all you have to do is find the slope first, or the rise over the run. You could do it in your calculator. I could show you how to do that in class. Or I could show you how to do it here on the video. The rise over the run, the rise is the y, the run is the x. So what you're going to do is you do y1 minus y2 over x1 minus x2. It doesn't matter which one you put, as long as you're consistent with the same coordinates first and the same coordinates second. So y1 will use 2 minus parentheses y2 will use -3. x1 will use -3 minus +4 for the x's. So you go positive, positive, you're going to get 5 over -7. So the negative goes in front. If one of them is negative, then the slope is negative. So we come back to fill this in. Y equals -5/7 x plus b. And all you got to do now is solve for the b, and you are done. The way to do that is to plug in one of the points. Doesn't matter which one you plug in. And so we'll plug in the first one. We get 2 for y. And you get -5/7, and then in place of x, we're going to put -3 plus b. We'll get a positive number. 2 equals +15/7 plus b. You're going to subtract both sides, 15/7 minus 15/7. So you're going to get b equals, and 15/7 is 2 1/7. So you're going to get -1/7 is left over. So our answer is going to be y equals -5/7 x minus 1/7. And that is going to be the equation of the line. We found that by simply finding the slope first. So we have our slope. Now all we have to do is solve for the b. You take one of your original coordinates, you plug it in for the x and the y, and then you solve for the b, and you plug that back in to give your two answers. Once again, you solve for the m and the b in these, the m and the b, and you're done. Just a two-step process. Once again, when you have your formula page, make sure you guys are writing everything down your formula page. I would put a lot of this on the formula page, the y equals mx plus b, this right here, how to find the slope. And in the next example, example 2, on page 75, example 10.2, it says find the equation of the line that passes through -2, 5. So they say the line we're trying to find has a point of -2, 5 on it. And it's also the line we're trying to find is perpendicular to the line 3y plus 4x equals 2. So this is not our line right here, but it is perpendicular to our line. Why is that important? Well, two things that you're going to take away. They're going to tell you the line that you're trying to find is parallel to a line or it's perpendicular. When it's parallel, it means the slopes are the same as the line you're trying to find. When it's perpendicular, it means the slopes are the negative reciprocal. So the flip and the opposite sign of the one you're trying to find. So this is perpendicular, so it's going to be the negative reciprocal. So first thing we need to do is rearrange this to slope-intercept form. This is slope-intercept form, y equals mx plus b. So we're going to rearrange this to slope-intercept form. The easy way to do that is 3y equals negative 4x plus 2. We brought the 4x to the other side. Then you divide everything by 3, isolating the y. When you do that, you get negative 4/3 x plus 2/3. You don't need that. The only thing you need is the slope, because it's perpendicular, it's the negative reciprocal. So this is not your slope, but it's the negative reciprocal of your slope. So this is actually an easier problem because we already know our slope now. So it is positive 3/4 x is our slope because it's the negative reciprocal of this. Now all we got to do, this point is on our line, we're going to take this point, plug it in for x and y, solve for b, and we are done. So anytime you're doing the perpendicular or the parallel, it's really quick and easy to solve for these. So take your 5 and put it over here in place of y. You get 3/4 in place of x. You're going to put negative 2 over 1 plus b. So this is going to be a 1, this is going to be a 2, so you get negative 3/2 plus b in your 5. So we're going to add 3/2 to both sides. So b equals, this is going to be 5, 6 and 1/2. So b is 6 and 1/2, or 12, 13/2 when you leave it as an improper fraction. So our line, the equation of the line, is going to be y equals 3/4 x plus 13 over 2. Not too tough. Remember, when we're solving for these, all you got to get is the m and the b. M is the slope. We found the slope from this line that wasn't our line, but it was perpendicular to our line. So we put it in slope-intercept form, and we found that this was the negative reciprocal of what we needed. So there's the opposite of that. Plug in that point, and you can come up with the answer here. Last one on this concept is in your book on page 76, example 10.3, and you're going to need your book to look at this one. What they did was they gave you a coordinate plane, and it has two different lines on it. So if you can see that one right there, A and B. Now if you look at A is simply going to be y equals negative 2. It's a straight line. Those are easy to figure out because you ask yourself, which axis is it crossing? And you can see right there, it's crossing the y-axis. So if it's crossing the y-axis, then it's going to be y equals something. And the second question you have to ask yourself is, where is it crossing the y-axis? And it's crossing the y-axis at negative 2. So those are quick and easy. Just look at it and you write it down. The other line here is the B line right there. And when you look at that line, you have to pick 2 points on your own. So I picked 2 points on your own, and they don't have to be exact. Pick the ones that are the closest. So I picked negative 1 and 6, and negative 6 and negative 5. And you can look in your book and see kind of where those exactly crossed. And really it's going to go back to the same as the first one that we did. Once again, you can enter these in your calculator and come up with a slope really fast and then just solve for B. Actually, I think you might even be able to solve for the whole thing. We can look at that, our programs. I don't have my calculator with me. But you can simply do it by hand. You have 6 minus y2 is negative 5. You have negative 1 minus negative 6. So it doesn't take long to do these. This becomes a positive, this becomes a positive, so you get 11 over 5 is the slope. So y equals 11/5 x plus b, and then you simply pick a point, doesn't matter which one. You plug in x and y to solve for the b. You're going to get 11/5 in for y, you're going to get 6, you're going to get negative 1 over 1 plus b. They're just really not that tough. So you get negative 11/5 plus b, add 11/5 to both sides. When you do that, 11 over 5 is the same as 2 and 1/5. So we get 8 and 1/5. So we're going to get 41/5 equals b. So in solving for this, we're going to have y equal, and we could just replace it up here if we want to, 41 over 5. So y equals 11/5 x plus 41 over 5. Those are not as intimidating as people make them out to be. The second concept on lesson 10 is called rational denominators. And basically, they're going to give us a fraction, and they're going to put something in the bottom that can't stay there. And so you have to have a rational denominator. This is an irrational denominator because it's got a radical in the denominator. Can't have that. You also cannot have an imaginary number in the denominator. So we'll get one of those here in just a second. Now, the way that you get rid of an irrational denominator is you multiply this, just like changing a fraction. You're going to multiply it by a form of 1, and you're going to pick the conjugate of this, which a conjugate means a twin. It's the same number except for the sign in the middle is different. Because whenever you do that, it's going to eliminate one of the numbers here. Now let's go ahead and distribute the top, and so you have to do what you guys call FOIL twice, or what you guys call FOIL. So you're going to go 4 times 2 is 8, 4 times 3 root 3 is 12 root 3, the 4 is done. Root 3 times 2 is 2 root 3, and then root 3 times 3 root 3 is going to be 3 plus 3 parentheses 3 because any radical times itself is itself, so the radical's gone there. Then on the bottom, we're going to get 4, and I'm going to write this down once, but I'm not going to do it again. We're going to go 4, we're going to get 2 times 3 root 3 is going to be 6 root 3. That's done. And negative 3 root 3 times 2 is going to be negative 6 root 3. I'm not going to write this again, but the middle term always cancels out in a conjugate. That's why we picked this particular number here. We picked it because when you add those two numbers together, you're always going to get 0. So there's really even no reason to FOIL that out. You only need 2 times 2, which is 4, and negative 3 root 3 times positive 3 root 3, which is negative 9 times 3. That's really all that you need there. And in simplifying this, let's go to the top. In simplifying the top, you're going to see 3 times 3 is 9. So 9 plus 8 is 17. So those are done. And then 12 root 3 plus 2 root 3 is going to be 14 root 3. Then on the bottom, negative 9 times 3 is going to be negative 27. Negative 27 times 4 is going to be negative 23. So this is going to be your answer. 17 plus 14 root 3 over negative 23. Nothing can be reduced. Nothing can be factored out of the top there because 17 is a prime number. And if you look in your book, you actually see that they have negative 17, negative 14, and positive 23. Always know if your signs are exactly the opposite of what they have in the book or what have you, it means the same thing. So this right here is the same answer as what they have in the book because all the signs are different. Look at the second example on page 78 at the bottom, example 10.5. You will see that it's the same as the last one. It has an irrational denominator. We have a rational denominator here. And the way, because there's an imaginary number there, you got to get that out of there. How do you do that? Same thing, you multiply it times the conjugate, which means it's the twin of this, except for the sign in the middle is different. This has a positive sign in the middle. We're going to put a negative sign in the middle. And remember, as long as you do it by the same thing over the same thing, we didn't change the equation, just changing the way it looks. It's a form of 1. If you divide this out, you get 1. So we didn't change anything value-wise. We just changed the way that it looks here. So let's multiply the top out, and we're going to FOIL it. Now, before we FOIL the top, we actually need to simplify the top. And the way you do that, I cubed, if you guys remember, is going to be negative I. So that is going to be positive I, because negative I, it's actually going to look like this. Negative times negative I, which becomes a positive I. And then right here, 2 to the 5th, if you get rid of 4, it's just 2I is all that's left over. You got rid of 4 of the I's. So you end up with positive I and 2I becomes 3I. So 2 plus 3I all over negative 2I plus 4 and then multiply negative 2I minus 4, negative 2I minus 4. So do FOIL. FOIL the top. You get 2 times negative 2I is negative 4I. 2 times negative 4 is negative 8. So the 2 is done. 3I times negative 2I becomes negative 6I squared. And then 3I times negative 4 is negative 12I. All over on the bottom, remember, I'm not going to do the middle terms. I'm just going to do the insides and the outsides because we know that the other ones cancel. That was the whole point of this thing. So negative 2I times negative 2I is positive 4I squared. And then 4 times negative 4 is negative 16. Now, in simplifying this right here, we're going to go, I squared is negative 1, so this actually becomes a positive 6. So on top, negative 8 and positive 6 is negative 2. Negative 4I and negative 12I becomes negative 16I. All over, I squared is negative 1, so this becomes negative 4. It becomes negative 20. Now, one thing that you can do, you can either leave them all negative or all positive, doesn't matter. But they all have a 2 in them. So you can factor out, I'm going to write it over here. You can factor out the 2. What's left over? What's left over is negative 1. They probably factored out a negative 2, it doesn't matter. But negative 1, negative 8I. And then on the bottom is negative 20. That becomes a 10, that becomes a 1. So negative 1 minus 8I all over negative 10. They probably, in the book, I'm not looking at it right now, they probably put negative 1 over 10 minus 8I over, plus negative 8I over negative 10. So what would happen is everything actually is going to become positive. So that's negative 1, that's negative 10. So it will become positive. We're going to get 1/10 plus 4/5 I. And that's what happens after you break it apart and reduce it. I know that looks like a lot. It really wasn't. We were just doing a lot of little steps. I didn't want to skip any steps right there, but not too bad. Remember, the problem is you can't have imaginary number or radical denominator. You multiply it by the conjugate, which means they're twins, they're the same, so the sign in the middle is different. The reason we do that is it gets rid of some things in the denominator. These are not too bad. The next concept is the third concept of lesson 10. It's also the third concept of lesson 11. So we're going to get two concepts done at once here. And it is the quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And they're going to give you something like this. They're going to say 3x squared minus 2x plus 5 equals 0. And then they're simply going to say use the quadratic formula to find the roots of this equation. Now, you can take this and plug it into here. This is the a, this is the b, and this is the c. So a is 3, b is negative 2, and c is positive 5. Now, you can plug this in and solve for it. Doubt you're going to do that because your calculator's going to do that for you. So you plug it into a formula on your calculator and solve for it. And when you do that, the answer to this is going to look something like this. X equals 1/3 plus or minus root 14 over 3i. And your calculator will do every bit of that for you. If you have trouble finding that program, I will help you in class on a question day. But those are not going to be difficult for you. The first and second concepts on lesson 11 will combine into one concept. And really it's just working on your understanding of how circles work. And the first thing we're going to look at is something called inscribed angle. And an inscribed angle, I'll show you what it looks like. If you have a circle and you have an arc, let's say, I don't know, it's the 30-degree arc. And it goes all the way, it touches that right there from that point to that point is a 30-degree arc, and it goes all the way to the other side. Well, an inscribed angle is what this angle is called, and it's inscribing this 30-degree arc. And this inscribed angle is half of its outer arc. So it's got these two chords right here. 30 divided by 2 means 15 degrees is what this inscribed angle is. And that looks pretty simple. So you're going to use your knowledge of an inscribed angle in order to solve for these. So if you will look at right here, here's an arc. And this arc is being inscribed by this 46-degree angle. So the inscribed angle is half the arc, or the other way to say it is the arc is double the inscribed angle. So you're going to get 92 is this arc from here to here is 92. Same concept's what we did right here. Well, if you'll notice, this same arc is also inscribing this x plus 10 degree angle. So if the arc is 92 degrees, and 46 is the inscribed angle for this arc, and this is inscribing the same arc, we can make a true statement by saying x plus 10 degrees equals 46 degrees. So x equals 36. And that's how you solve for x right here. Same concept going the other way, and I'll put a blue marker up here. If you look at this arc right here is being inscribed by that 30-degree angle. So that's half of its arc. So its arc is double that. So 60 degrees is this arc right here. Well, inscribing the same arc is, if you look, I know it's two different inscribed angles, but if they're inscribing the same arc, then they are equal. So 30 is going to be equal to y plus 20. Subtract 20 from both sides. Y equals 10. So we just solved for x and y using the concept of inscribed angles. Remember the rule is an inscribed angle is half of its arc, or its arc is double the inscribed angle. So you have 15 and 30 is their relationship. We use that for something like this. And you have to kind of look at it and really think about it. And don't panic when you see these types of problems. I look at these types of problems as solving a puzzle. But same concept as the one we just looked at. I know it looks different as far as the shape inside the circle, but all this is a bunch of inscribed angles. And you see, they gave us 75, x, y, and 80. These are all inscribed angles going at different arcs. And so we have four arcs here. We have one that's 50 degrees, one that's unknown, one that's unknown, and one that is z degrees. Now, if you will notice, and I'll try and use another marker to be able to show you this 80 degrees inscribed angle. You see where its arms are going off here, and what it's doing is actually it's adding two arcs together. So 80 is going to be equal, this 80-degree angle, or if you double it, you get 160. So this whole arc added together, 160 degrees is going to equal z plus 50 degrees. Because remember, the arc is double its inscribed angle. If 80 is the inscribed angle, you double this whole arc, and that goes from here to here. You've got to kind of be able to break it down and not look at the whole picture, but just the little picture here. So we made a true statement. If the whole thing is 160 because it's double 80 degrees, then you say that 160, the whole arc, is equal to 50 plus z. So z is 110. So we get right up here that z is 110 degrees, whole thing is 60. Now we can focus on a different arc. Right here, what about the 75 degrees? And just solve for what you know a little bit at a time. So here you have the lines coming off 75, and so 50 plus this blank, this question mark here, is 50 plus the question mark is inscribing the 75. So the whole thing is going to be 150, therefore this has to be 100. So if you have 110 and 100, that's 210. 50 is 260. If the whole thing is 360, then this has to be 100 degrees also. So we just solved for everything all the way around. So let's look at another inscribed angle we're going to bust out all the colors today. So we get from the x. So from the x is inscribing the 100 plus the 100, so 200. So x has to be 100 degrees. And then the last one here, bust out one more color, orange. So the y, look at the y coming off here. So the 110 and the 100, y is inscribing those two arcs. So 210 divided by 2 is 105. So we get y is 105, x is 100, z was 110, and I think that was all that we needed to solve for. So that was example 11.2 on page 86. Same thing, another example. Focusing on the concept of inscribed angles, you see 75 here. If you draw it all the way out, 75 is inscribing the x, so if you double 75, x is 150. You look at the 35 is inscribing the y, so you double that, y is 70. And then you have the z over here is being inscribed by the third angle of this triangle. Well, if you use your rules of triangles, these two added together are 110. So if triangles all add to 180, this is 70 degrees. Therefore, z is 140 because it is inscribing the 70 degree angles. Or you could have added 150 and 70, subtract from 360 to get 140. Doesn't matter how you go about it, just whatever you see fit. Once again, using the inscribed angle concept to solve for the missing pieces of the puzzle. We're actually going to take this next problem in a different direction. This is on page 86, example 11.4. And you have these two chords here that are crossing, and you have values for each. And the way that you're going to solve for this is you're going to say x plus 5 times 20 is equal to 15 times x plus 10. You have one variable, one equation you can solve. So you're going to distribute 20x plus 100 equals 15x plus 150. Bring 100 to this side, bring 15x to this side. You're going to get 5x equals 50, divide by 5, divide by 5, x equals 10. Not too tough. You just got to know how to start with this one right here, and then it's just a simple solving for x problem. Once again, this is just going to look at our knowledge of circles. And before we had something crossing inside the circle. This time we're going to have a triangle with a circle inside it. And anytime you have this, you actually create three equal sides to each other. Three isosceles triangles is what these are. So if you have an isosceles triangle, remember isosceles triangle means it has two equal sides. So we're actually going to have 6 equals x plus 4, and that is a 4 and that is a y. And x equals x, that doesn't help us. And you have 10 equals x plus y. Very simple, you solve for the top one first. So x has to equal 2. And then if x is 2, then y has to be 8. So not too difficult, but once again, you have to know how to start. And the rule you have to remember is that whenever a circle's inside a triangle, 3 isosceles triangles are created. So therefore this side equals this side equals this side, and this side equals this side. And then you can solve for it knowing those rules. The last concept that we're going to look at in these lessons that range from lesson 10, 11, and 12. The last concept is going to be diagonals and exterior angles, interior angles. They're going to ask for the sum of the measure. They're going to ask you for the sum of the measure of the exterior angles, the sum of the measure of interior angles, and then they might ask you for the number of diagonals in a triangle or diagonals in some sort of a shape. 9-sided shape, 5-sided shape, 6-sided shape, and some sort of polygon. So the number of exterior angles of any sided polygon is always 360. It's a trick question. Anytime they ask you, find the sum of the measure of the exterior angles of a 7-sided polygon, the sum of the exterior angles is always 360. Nothing to figure out. The interior angles, you're going to take the number of sides minus 2 and multiply it times 180. So it's not hard to get in the interior angles. And then the diagonals, you take the number of sides times the number of sides minus 3 divided by 2. So all of these are plug and play type problems. You need to write these three formulas down and then you solve for them. Something to look at, and we can look at this. Lesson 12 is your homework, so you get a little bonus here. But if you look at number 4 from lesson 12, it says find the sum of the measure of the interior angles, the sum of the measure of the exterior angles of a 6-sided polygon. So a 6-sided polygon, what is the sum of the exterior angles? It is always 360. Okay, well, what about the interior angles for number 4 on page 95? I'll write this up here. Number 4, lesson 12, page 95. And they're wanting to know a 6-sided polygon. Well, the interior angles, you're going to plug it right here. N minus 2 times 180. The number of sides is 6, so 6 minus 2 times 180, 4 times 180, which is going to be basically be 360 times 2 is 720. So 720 degrees is the measure of that. So that's how you would solve for number 4 of a 6-sided polygon. Then you look at number 5. Number 5 says how many diagonals can be drawn in a 9-sided. So number 5 from lesson 12. They want to know a 9-sided polygon. How many diagonals can be drawn? Well, you plug it into here. 9 times 9 minus 3 all over 2. 9 minus 3 is 6. 6 times 9 is 54 divided by 2. The answer is 27 diagonals can be drawn. So that's the answer to number 5. So simply 3 formulas that you need to place on your formula page has to do with different sided polygons, that the sum of the exterior angles, the sum of the interior angles, and then in any sided polygon, how many diagonals can you draw inside that thing? Well, it depends on how many sides, and you plug it into your formula. That is it for lessons 10, 11, and 12. You're now ready for your homework for lesson 12. If you have any questions, bring them to class.